So you have read that precipitation can be computed or collected using the different rainfall measurement gauges. And then our next task is to solve the areal precipitation. Okay, so there are in here we are going to talk about three methods. The first one is the arithmetic mean method. This is the simplest way of obtaining average precipitation. This is simply getting the average of all the different rainfall gauges located in the catchment area or in the basin. Okay, so this formula is actually the formula for average, for the mean. Okay, the second one is the Thiessen polygon method. Okay, so this method attempts to allow for non-uniform distribution of gauges by providing a weighting factor for each gauge. The stations are plotted on a base map and are connected by straight lines. Perpendicular bisectors are drawn to the straight lines joining adjacent stations to form polygons, known as Thiessen polygons. Okay, so we are going to illustrate this one later on. So how are we going to use the Thiessen polygon? And then the third one is the Isohyetal method. Basically, this one is I think this cannot be done using bare hands. We are going to use softwares for this one. All right, so let us start with the first example. So let us consider the following idealized basin with 6 rain gauges with annual precipitations: S1 837.3 mm, S2 1106.1 millimeters, S3 1014.8 mm, S4 686.9 mm, S5 641.8 mm, and S6 is 1137.3 mm. Alright, so as you can see in the figure, we have a rectangular basin. Okay, in real life, we do not have actually a rectangular basin. All basins are irregular. Okay, so that is why it's called an idealized. Okay, this is an idealized basin because we cannot see something like this in the real world. For the ease of computation, we are going to use a rectangular one. Okay, so as you can see, inside the basin there are 6 rainfall gauges. Okay, so we have S1, S2, S3, S4, S5, and S6. All right, and each of these gauges have measurements. Okay, so every measurement is given. Now we are going to use for the arithmetic mean, the Thiessen polygon, and the Isohyetal, if this is applicable. I mean, if we can do this one. All right, so first one, let us do this by arithmetic mean. So by arithmetic mean, we are going to use the formula, the summation of all the measurement divided by the total number of measurement. All right, so basically 1 over n, that's 1 over 6 because there are 6 measurements. In this case, there are 6 gauges inside the basin, and the summation of all the rainfall gauges measurements is the sum of all. Okay, so we have 1 over 6 times the sum of all these measurements. We have 5424.2 mm, and therefore the average is 904 mm. So this is our answer using the arithmetic mean method. For the next one, we are going to use the Thiessen polygon method. Okay, so I am using AutoCAD to draw the Thiessen polygons. So it is easier not to use software like AutoCAD. The first thing that we need to do here is to draw a line from one station to the next station. Okay, so for this one, I'm going to draw a line from S1 to S2. Okay, and then after drawing a line from S1 to S2, I'm going to draw a perpendicular bisector of S1 and S2, meaning I have to draw another line perpendicular to this line, and it should be exactly at the middle. It will divide this line into two equal measurements. So I'm going to use construction line, and I'm going to use angle and then reference. Okay, and then I'm going to use 90, right? And it should be at the midpoint. Okay, so that is our perpendicular bisector. Okay, let's do another one from S2 to S6. Okay, let's draw a line from S2 to S6 and draw a perpendicular line, a perpendicular bisector. Okay, so our reference is 90 degrees and should be at the midpoint. Right, then let us draw a line from S6 to S3, and then let us draw a perpendicular bisector. Okay, I'm sorry, so I'm going to draw. Okay, so reference is 90. Okay, and should be at the midpoint. Okay, all right, so if you take a look at this one, these two perpendicular bisectors meet at this point. So I think we need to trim this one now. Okay, and then we need to trim this one also. Alright, so basically they meet at this point, so we leave it like that. Okay, and then we connect S3 to S4. Okay, so S6 is already isolated, ano? So kanya sa S6 na to, itong area na to. But as you can see dito, S2 and S3 are still lying in the same area. So we need to draw a line from S2 to S3 as well. Okay, and then a perpendicular bisector. Should be at the midpoint. Okay, and it should meet exactly at that point. So nag-meet ulit itong mga tatlong perpendicular bisector. So I need to trim ito. So wala na yan. Okay, so nag-meet din itong dalawang ito dito. So yan, wag ko munang i-erase yan kasi magagamit ko pa dito sa kabila, no? So since ito, parehas lang, mirror lang dito sa kabila. So we do the same, S1 to S4, S1 to S5, tsaka S5, S4. Okay, so itong perpendicular bisector ng S1 to S4 ay ito din, parehas din ta. So yung perpendicular bisector na lang ng S1 tsaka S5. So I'm going to use construction line, angle, reference, and then click natin to, and then 90. Okay, tapos dapat sa midpoint. Okay, and then we do the same, construction line, angle, reference, click natin ito, and then 90. Tapos, dapat sa midpoint. Yan. Okay, so, we trim just the same. Okay. Yan. Okay. So, i-click natin yung mga perpendicular bisector. Ito, this one, and this one. Okay, wait. I'm going to trim this here. Yan. Select natin ulit yung mga perpendicular bisector natin. So, these are our perpendicular bisector. Palitan natin yung kulay, ano? Para makita natin. Okay, gawin natin black. Tapos, yan. Palakihin natin. Yan. Okay, as you can see right now, so our areas, the basin is divided, ano, using these perpendicular bisectors. Okay, S1, sa kanya itong area na ito. Alright, S2, itong area naman ito. S3, S4, ito sa S5, and this one sa S6. Okay, na-notice nyo siguro that S1, S2, S3, and S4, they have the same areas. Tapos parehas naman yung area ng S5 tsaka S6. Okay? So, dito kasi sa AutoCAD, meron tayong pwede nating makuha yung area ng bawat isa without actually computing, ano? So, type na lang natin yung area. Na-type ko na. And then, select yung mga corners. Just select the corners. Una, ano ko muna itong total area. Corner ng rectangle natin. It should be equal to 1,800. And then, enter. So, we have 1,800 yung area niya. Kasi nga 60 by 30 ito. Okay? So, we are correct. Now, let us compute for the area of ito. The area for S1. So, area. Tapos, specify lang natin yung mga corners. Okay? Okay, so, ang area natin ay 262.5. Okay? So, the area for S1, A1 is 262.5. So, basically, pare-parehas na itong area ng S1, S2, S3, and S4. They are all 262.5. Okay? So, ito na lang, S5 tsaka S6. Okay? Ulitin natin, the area for S6 ay 375. Okay, so we have 375 area for S5 and S6. For S1, S2, S3, and S4, we have 262.5. Okay, so let us go back to our presentation. I-consider natin yung area na yan. Now that we have computed for the area of each of the stations using the Thiessen polygon, now we can solve for the average precipitation. The Thiessen polygon is like it's like an average mean or weighted mean. Okay, it's like a weighted mean. For each station, there is a weight, and that weight is the area that we have computed from the Thiessen polygon. Okay, so our formula is the summation of area times the precipitation divided by the summation of all the areas. So the numerator is equal to the product of the area and the precipitation. Okay, so for the station 1, the area is 262.5. and the precipitation is 837.3. Okay, so this 262.5 came from the Thiessen polygon dun sa AutoCAD natin kanina. Itong 837.3 come from the measurement at the station. This is given in the problem. Okay, so plus this is the second station. The area is 262.5. The precipitation is 1106.1 mm. This is for station 3. This is for station 4. This is for station 5. And this is for station 6. Okay? And the total area is 1,800. You should double check this kasi dapat the sum of all the area should be equal to the total area na 1,800. Okay? Computing, we have this one and we come up with 902.2 millimeters. Okay, so this is the area. This is the average precipitation for the area. Okay, so this is now our final answer using the Thiessen polygon method. And for the last one, we are going to compute for the average precipitation in the basin using the Isohyetal method. Okay, drawing the isoheights is just like drawing contour lines in your surveying. Okay, so I'm not going to focus on this one. Medyo mahirap na gawin, most especially now that we are online. But if you know how to draw contour lines noon sa surveying ninyo, madali lang din ito ang gawin. Okay, so basically itong linya na to are called isoheights. Itong isoheight na to, this is 1,200. Ang ibig sabihin nito, this line sa linyang ito, lahat ng precipitation dyan ay 1,200 mm. Okay, itong linya na to, this is 1,100 mm. Okay, as you can see, between 1,100 and 1,200, nandun dapat yung 1,106 at saka 1,137. Okay? So, ito namang linya na to, this is for 1,000 mm precipitation. Okay? And then 900, 800 mm. As you can see, itong 837 should be between 800 and 900 and so on. Okay? So, if you need to review drawing the contour lines, itong isoheight, you can do so, but I'm not going to give something like this in the exam, but maybe in the problem set, no? So, how do we do this? Okay, so the formula is still the same. It's like Thiessen polygon method, but this time the area, for example, the area is between two isoheights or isohyetal lines. Okay, so for example, we are going to compute for 500 and 600. We are going to compute for this area right here. Okay, computing for the area is even more difficult kasi hindi na siya regular, this is an irregular one, so you need to compute for this area. Okay, so kapag ginamit niyo AutoCAD, meron ding meron ding automatic na command sa AutoCAD because this is a region. You can just click this region and then i-compute na niya yung area. Okay, so the precipitation inside this one, kasi hindi natin alam, is the average of the two contour lines. Okay, so 500 and 600, the average is 550. So yun yung gagamitin natin na rainfall measurement dito sa area na ito. Okay, and then ganun din ang formula, area times precipitation, isum natin lahat-lahat divided by the total area. So this is now the computed, so This is from the book na pinagkuhanan ko ng problem na ito. So we don't need to do this, but the area between lines, this is a fractional area. Ibig sabihin ng 0.05, this is actually 5% of the total area. Hindi siya 5.05 square kilometers, but this is 5% of the total area. Okay, that is 10%, 11%, and so on. The total should be equal to 100%. Okay, and then effective precipitation. The effective precipitation is the the product of the area and the product of the area and the precipitation. For example, itong una, this first column is actually for this one. Okay, so since wala tayong lower bound, the lower bound is 400. The average between 500 and 400 is 450. So 450 times 0.05, we get 22.5. Dito naman, since the isohyetal line range is from 500 to 600, so we have 550. Okay, the average 550, multiply natin sa area na 10% or 0.01, we get 55. Okay, we do that for all the remaining columns. Nandiyan na yung mga effective precipitation. So to compute for the average precipitation, lang natin, bali ito na yung sum nito is actually yun na yung numerator natin. The sum of this one is the denominator because this is the total area. Okay, and basically we will come up with an average precipitation. Okay, we will come up with an average precipitation of 902 mm. Okay, this 902 mm is almost the same with our answer in Thiessen Polygon method. Okay, so that's it for the areal precipitation. So we can solve areal precipitation using the arithmetic mean method, the Thiessen Polygon method, or the Isohyetal method. Okay, if you have any question about this one, please do so in the comment section. Alright, so I will see you in the next video.